All right, everybody, we're going to go ahead and start the session. So welcome. This is Introduction to Open Source Mapping with ArcGIS Location Services. My name is George. This is Anita. We'll be presenting today. We are members of the developer experience team at Esri, and we work with open source tech, especially JavaScript mapping libraries, which is what we're going to cover today. So I'll hand it off to Anita and get this thing started.
All right, thanks, George. I know we're going to have a little bit of audience participation. And just as a show of hands, how many of you have actually used an open source library like Leaflet or OpenLayers? Oh, wow, that's great. That's awesome. Yeah, so just as a quick introduction for those of you who haven't used open source mapping libraries, Leaflet is a lightweight library with a very small footprint. MapLibre GL JS is the open source fork of Mapbox version 1 before they changed their business model. OpenLayers is a pretty long-lived library, and it has very strong GIS support. It's been around for, how's it now, 20 years?
Since 2006, yeah.
2006. And then CesiumJS is great for 3D visualization. A question that we get asked sometimes is like, well, why use an open source library? And there are a variety of reasons why you would use one. Some people really like that there's an open source community, there's a lot of collaboration, and there are smaller modular footprints compared to some other libraries. And for other people, it is that your solution does need open source technology in some capacity. For ArcGIS resources, what resources are supported? Definitely the base map style service is supported. The feature layers, you can access your feature service as GeoJSON in MapLibre GL JS and OpenLayers, among others. You can also access your vector tile layers, your map tile layers, and in CesiumJS, you can also access your scene layers as well. And then if you're using ArcGIS REST.js, you can also access places, service, geocoding service, spatial analysis, and others as well. However, there are some limitations of third-party libraries, particularly if your solution wants to use a web map or web scene, then open source libraries aren't for you. I would suggest using the JavaScript Maps SDK. And if you want to make use of a lot of the widgets that you see in the JavaScript Maps SDKs, you're going to have to do a lot of work in open source libraries to have that functionality as well. And then any type of like really advanced data visualization that you want to do, the JavaScript Maps SDK is a better solution for you than an open source library would be. However, there are some additional features in Esri Leaflet. So if you want to use Leaflet, then you should, Esri Leaflet is a good option for you if, say, you want to access your feature service, your vector tile service. And we also have specific vector base map layer plugins for you to use, and also a geocoding widget so that you can geocode without using REST.js. We also have additional heat map and cluster rendering as well for it. So I created this table for you to just ask yourself, okay, what does my solution need? Do I need to use web maps? Do I need to use web scenes? Use the JavaScript Maps SDK. But if you're really committed to having a small modular footprint, if you really want that open source community, then Leaflet, CesiumJS, MapLibre GL JS, or OpenLayers would be your best bet. I'm going to go through this table in a little bit more detail, but please feel free if you need to take pictures. I'll stay on this slide for a little bit.
And these slides are going to be posted after the talk as well.
That's right. OK, that was a really high-level view of these open source libraries. So now let's go into their capabilities just a little bit more. In terms of maps and scene support, all of them will support 2D visualization. MapLibre does support 2.5D. And then if you want your full 3D capabilities, then CesiumJS is the library to choose. And then for data and layer support, Leaflet and OpenLayers do not inherently support WebGL as compared to, say, MapLibre and CesiumJS. But all of them will support GeoJSON features, and all of them, to a certain extent, will support ArcGIS data services. As I said earlier, you can access, say, your feature layer using GeoJSON, but if you want to do additional things like querying your feature service, you would have to use REST.js for that. All of them support map tiles, also known as raster tiles, but CesiumJS does not support vector tile layers. And then for Leaflet and for OpenLayers, you'll need to use an additional plugin. So if you're using Leaflet, Esri Leaflet would be a good option. You could also use, say, the Leaflet vector grid layer plugin as well. And for all of our demos, we use the OpenLayers Mapbox style plugin for OpenLayers to render our base maps and other vector tiles layers. And then in terms of data styling, like OpenLayers and Leaflet and MapLibre and Cesium, they can all do styling in GeoJSON. They can, to a certain extent, for at least OpenLayers and Leaflet and MapLibre, style vector tile layers. And then to some capacity, you can also style map tiles as well. Now, George and I thought this would be kind of cool to see the comparison of library file sizes. And by far, Leaflet is the smallest, as well as Esri Leaflet, followed by MapLibre GL JS, and then the biggest by far is CesiumJS, but that is, of course, because of all of the 3D capabilities that it has. I think one of the hallmarks of open source is this idea of community and community involvement. So we both thought that this was an important metric to include here, as what are the GitHub stars? What are the weekly NPM downloads, the Stack Overflow questions, and the percentage in which those overflow questions are answered. So in general, I think all of the libraries are pretty comparable in terms of the Stack Overflow questions answered. We do see that MapLibre is significantly lower, but that could also be because it is pretty new. It came out right after Mapbox changed their business model. So it's been a couple years. All right. Now we can get to accessing ArcGIS services. So in this talk, we're mainly going to focus on the base map style service as part of location services, and also the data services, your feature service, vector tile service, and map tile service. And we decided to divide it up like this because for the other location services, places, geocoding, routing, geo-enrichment, you'll have to use ArcGIS REST.js for that. And George and I have another talk specifically about REST.js and using open source libraries with it on Friday. All right. So to get started accessing location services, you can always go to the developer's website, and you'll need an ArcGIS account. So this is either an ArcGIS developer account or an ArcGIS online account. And you'll need an access token. So this can be an API key or a token generated from an OAuth workflow. And once you have an account and an access token, then you can start accessing location services and displaying your whatever results you have on the library you choose. All right. So the first service that I'm going to cover is the base map style service, because a base map is the foundation of your application. And it provides the style and context for your solution. There are many different styles available, and you can also create your own custom styles. So I'm going to show, do you want to change it to my laptop? So I'm going to just show the base map style service. This is on the developer's website, and I'm on the base map style service API reference. And the reason why I'm here is because we list out all of the styles that are available that you can choose from, anywhere from streets and navigation to topography and imagery, and then of course we have OSM styles as well. The reason why we're able to access our vector-based maps in open source libraries like MapLibre and OpenLayers and others is because we have two options of how we return the JSON. One as Mapbox style JSON, and then the other as ArcGIS web map JSON. So Esri Leaflet and the others, we are able to get this vector-based maps back because everything complies to Mapbox style JSON. So to demonstrate how to actually access our base map, I'll go to the documentation site, and I am going to choose, do you want MapLibre or OpenLayers? I give you the choice. MapLibre, okay. All right. So I'm on the MapLibre documentation, and actually on this Where to Start section in the overview page, I can click on this View in CodePen button. That will take me to CodePen and give me all the code I need to actually build my Hello World app. All I need is an API key, so I will just get one from my dashboard, and note that it is scoped to access the base map style service. Right. So I will use that in. Okay. So I did my Hello World app. How did I do that? I used the MapLibre GL JS map class, and then for the style parameter, I set the style URL. It's really easy to update the style. All I have to do is change this to anything like ArcGIS community. And I can do one more. Let's do ArcGIS light gray. That's it. So that's with MapLibre, which natively supports vector tile layers. But if you want to use, say, OpenLayers, you're going to have to use a plugin. I mentioned earlier that we use the OpenLayers Mapbox style plugin. And for that, you just need to scroll down just a little bit more. I'll just open up the CodePen for this. Okay. And for that, you just add the script for it. And then down in the code, you use the olms.apply method, and then you just set the base map URL in the same way that we did earlier with MapLibre. But if you want to use Esri Leaflet, we have the vector base map layer plugin. And for that, all you have to do, I will scroll down again to the Esri Leaflet doc, is load Esri Leaflet, JS and CSS libraries, and then use the vector base map layer. So that's a very brief look at how to access the base map style service. So I'm going to go now to the feature services. And then I just have to, yeah, feature. Cool. All right. So you can import your data into ArcGIS using any type of like CSV, XLS, Google Sheets, GeoJSON, those types of formats. And you can access your feature layer as GeoJSON. However, it's important to note that there are some scalability and caching issues when you do this. For example, if you have a feature layer and there are 200,000 features, for instance, there are some scalability concerns and there are some performance issues that you can encounter, which then you would have to use a vector tile layer for that. And there's also some caching concerns as well. You can't take advantage of the capabilities of feature layer caching in open source libraries, and if you want to, then you should use the JavaScript Maps SDK as well. All right. So in Esri Leaflet, we do have a feature layer class that you can use. So I'm going to go back to the documentation where we have a specific tutorial on how to add a feature layer. And really, this is the entire code that you need. You just need to use the feature layer class and then set the URL to your feature service, in this case, trailheads. It's a little bit more, I wouldn't say complicated, but there are a couple extra steps that you have to do in MapLibre, for instance. So in MapLibre, as I mentioned earlier, you're going to have to return the features as GeoJSON. So for that, you have to add a source, in this case for trailheads, and specify the type of data this is, in this case, GeoJSON. For the data parameter, then you set your service URL, but note at the end that we need to do a query, return the features as GeoJSON, and the query that you're doing is to return all of the features there. From there, you're going to have to add a layer which references that trailhead's GeoJSON source that we had, and then specify the paint that you want. In this case, up here, we can see that we painted it as with a white circle and then a black interior. OpenLayers is similar, and I think that's pretty much, yeah, my section.
Awesome.
All right, so now I'm going to pass it over to George to talk about vector tile layers.
Sweet. Thank you, Anita. Should I put this up here? Oh,
If you want.
Awesome. Well, hi, everyone. I'm going to go through a couple more of the different data services offered by ArcGIS and show you guys how to load them in to different open source libraries, starting with the vector tile service. So this is a type of data that has become way more popular recently. It serves data in the form of vector tiles, which stores vector data such as features, but in a tile format. And this makes them way more performant and a lot better optimized for displaying large amounts of features. You can see in the image here, we're displaying like individual house parcels, I think this is, and it's performant at a scale that feature services just really can't be. And this is because the tiles are returned as like pre-cached tiles containing features in what's called a PBF format. And the great thing about these tiles, as opposed to map tiles or image tiles, is that they still contain features with all of their attributes. So if you wanted to query your data, that's totally an option with vector tile services still. To create a vector tile service, you can publish an existing feature layer that's hosted in ArcGIS. All you need to do is go to your ArcGIS online portal and click Publish as Vector Tile. And it'll create a new vector tile layer hosted in ArcGIS Online. And to load it in to your application, let me just show you an example using MapLibre. So just tap out here. Oh, I have to close the presentation, don't I? Tragic. Okay. So here is a MapLibre app I whipped up that displays a vector tile layer. And this layer represents census tract designations for LA County. So this is LA County, and if we zoom in, you can see all of the census tracts here, just delineated by simple outlines with this example. So immediately, one really great thing about vector tile layers is their performance. You can see this layer probably contains like 20,000 plus features, and yet I'm able to zoom in and out really smoothly with no loss of performance. This is just would not be possible with a feature layer. And MapLibre in particular is really great for vector tile layers. This is partially because Mapbox originally published the vector tile spec, which is the open source specification for vector tiles. And MapLibre, for that reason, is still the all-around most performant for using vector tiles. It also makes it really easy to style them, which we're going to look at in a second. But let's dive into the code so I can show you guys how to load this layer. So here is the code for this app we were just looking at. And you can see right away we're doing the same thing that Anita was doing. We're loading the ArcGIS light gray base map. And this is the base map for the application. Fun fact is that our base map style service also uses vector tile layers for everything. So this ArcGIS light gray base map you're looking at is the same file format. It's a vector tile layer. Yeah, so all you need to do to load it is set the style parameter. And once the map is loaded, this is how you add your vector tile data. To add the data, first you need to add a Mapbox source using the map.addSource class. I'm calling it enriched tracks, the census tracks. And all you need to do is paste in the URL of the service. So this is the vector tile service, and it's hosted in ArcGIS Online. If we follow this link and remove the tile at the end, you can see here's the data. So this corresponds to an item in ArcGIS Online. The service item ID is right there, so you could find it in the portal. And yeah, this is all you need to do to add it, is add the source. And then to style it in MapLibre, you add in a layer. And this layer class is what contains all the styling information for your layer. Very importantly, I'm pointing the layer to the source. So you can see the source parameter I'm setting to be enriched tracks. And this is the thing we just made here. So the layer points to the vector tile service in kind of a roundabout way. And then here is all the styling information. I'm telling it to display as polylines. So there's no fill. It's just like simple outlines. And I'm setting the line color to this kind of boring gray and setting the width to 1. And that is what results in this app. So really easy. And in just a few lines of code, we've loaded our data, and it's super performant. One great thing about MapLibre is the style specification. And this is something that pretty much, if you choose MapLibre, Leaflet, or OpenLayers, with our technology, you're going to be working with the style specification because somehow they all use MapLibre in one way or another under the hood. But yeah, you can do a lot, especially with vector tiles, using the MapLibre style spec. So let's take a look at another app that uses the same data, but it just styles it in a bit more interesting ways, and it uses data-driven styling to actually access attributes. So yeah, this is the same census tract data, but now it's showing the average house price per parcel, and it's using this kind of gradient. So the darker blue corresponds to higher house prices. You can see over here in like Beverly Hills, the average home price is like $2 million, $1.5 million, a little out of my budget, honestly. But yeah, if we look closer to downtown LA or like Echo Park, down to like 500K, 400K. And so not only are we able to style the vector tile layer based off of the data, but you can see I'm also clicking on parcels and we're requesting the data for it and a pop-up. So we'll show you guys how to do this as well. And then the legend, this is something that would be way easier to do in the JavaScript Maps SDK. I actually just made this gradient myself. But if you use the Maps SDK, there's a legend widget. So kind of alluding back to what Anita mentioned, how there's maybe more built-in widgets in other services. But let's look at the code for this one. And it's going to look almost exactly the same, but just with more styling information. So you can see we're adding the layer, still pointing to the same enriched track source. But here in the paint class, I'm using the MapLibre style spec, and this is fully documented on their website. I'm setting the type to fill this time, and I'm setting the fill color to this linear interpolation of an attribute in the layer. So you can see, really, this is the magic line here. We're getting the attribute average value CY, and you know how it is with attribute names. They're kind of confusing, but this contains the average home value for the census tract, basically. And then, everything less than $500,000, we're mapping to this color. Everything between 500 and 700K, we're mapping to this color, kind of so on and so forth. So this is what results in the kind of mapping, in this color being displayed, which is great. And then to display this pop-up, the average home price, this is something else that MapLibre is very good at, which is querying the values on click for a vector tile layer. And that code is a little further down. So you can see we're adding an event listener. When you click on the map, specifically when you click on the census box layer we added, we're just checking out what feature was clicked. So getting the first feature clicked on the event, and then creating a pop-up that has the information in it. And the rest of this code is honestly just formatting it to make it look like a dollar. But yeah, this is the MapLibre pop-up that you see on the map. So pretty easy and pretty simple, and it's a really nice kind of lightweight way to visualize your data. So surely a bunch of use cases for this. Awesome. So going back to our slides, the next thing we're going to talk about is another type of data service called a map tile service. And this has been around for much longer. They're also known as raster tiles or image tiles. And basically, these are static image tiles that get displayed on your map. Surely, y'all are familiar if you've seen like a satellite imagery base map before. Any kind of raster data you can publish in ArcGIS Online. and serve it and into your application. The way you access the data is pretty much the same as what we saw for feature and vector tiles. You just take the service URL, put it into your app, and it'll magically display. The great thing about these is that not only can you display image tiles in it, but they're also not only can you display like satellite imagery in it, but they're also fairly performant. You can actually publish your feature layers as map tiles as well using ArcGIS in pretty much exactly the same way as you would with a vector tile. You can go to your ArcGIS online portal, click publish as map tile, and one reason that you might do this instead of a vector tile is that map tiles are pretty much supported by everything, and they're just as fast, if not even faster, than vector tiles. The only drawback is that there's no underlying attributes, so I wouldn't be able to query that data that you were just seeing in the vector tile layer. It would just be basically a static image. But still super useful, especially in apps like Cesium, where Cesium unfortunately does not support vector tile, so you'd be stuck with map tiles. But let's take a look at some other demos here using OpenLayers and Cesium, just to show you how to display these images. So going back to the app, here is an OpenLayers application that adds in this image tile service or map tile service. And it looks very similar to the vector tile service, especially because we're using very similar data. Again, it's LA County. This time it's house parcels instead of census tracts, so it's a lot more detailed. And if you zoom in, you can see each individual house here. And it is loading it as image tiles. I think, let me just refresh there. But yeah, if we check out the network tab here, you can see it's actually requesting, I think, like PNG images for each tile as we scroll. And this is as opposed to the vector tile, which would basically just be requesting a giant chunk of GeoJSON. So you can see as I scroll, like this is one image tile that's getting requested and loaded onto the map. So yeah, pretty simple to add this thing as well. Let's head to the code, and we can check out how to do this using OpenLayers. Yeah, again, this is OpenLayers, not MapLibre for this one. So yeah, we start by doing something very similar to what we saw Anita do, creating an OpenLayers map. And then down here, we're adding the base map using this olms.apply function. So the base map is still a vector tile layer in this demo, but the data that we're displaying is a map tile layer. To add this using OpenLayers, you use this ol.layer.tile class. And you have to point to a source, just like with MapLibre. We're using what's known as an XYZ source, and here is the magic service URL. So this is what's actually pointing to our data. And you can see all we really have to do is point OpenLayers to the URL, and it's going to find it and load it into the map. So this is the entirety of the code for this one. Very simple. Yeah, so let's take a look at pretty much the exact same demo, but using CesiumJS instead. And I did mention that Cesium does not support vector tile layers, so this is a much stronger use case for this library, honestly. And Cesium is a lovely library in that it has full 3D support, so I can actually like zoom and pan here, and I've even added terrain, so this can really enhance the visualization quality of your data. Again, this is the same data we just saw, but since we're in Cesium, we can zoom in and check out all of the Santa Monica Mountains and maybe gain a little bit more understanding about why the house parcels are the way they are. So you can see, like, without the imagery and terrain, you might not understand, like, oh, these are actually like beach houses down here. Maybe that's why the parcels are so small. Whereas up in the hills, it's pretty much just uninhabited terrain, thus resulting in much larger kind of parcels. So, I mean, this is all just like my estimation looking at this app, but you can see how it can really enhance the quality of a visual analysis that you do. Yeah, and I've just styled this layer to make it orange instead of blue using Cesium to make it a little bit easier to see against the satellite base map. We're actually using image tiles for the base map here as well, because Cesium doesn't support vector tiles. This is the ArcGIS satellite imagery base map. So to make this work in Cesium, it's still pretty easy. It's a little bit different from the other ones. So let's look at the code for the Cesium app, and we can see exactly what's going on. Again, with all of these libraries, you want to reference the library imported at the top of your file. We're using a CDN reference for everything, but you could also install this via npm or whatever your preferred method is. And then here in the code, this is where everything is happening. I don't think we've looked at a Cesium app yet, so I'll just step us through how it all works. But instead of a what's known as a map in Cesium, you use a viewer because the viewer has full 3D support. So you might be making a 3D scene or displaying buildings, which we'll look at in a second. So we're making a new Cesium viewer, and this is what's actually rendering all the data to the screen. To set up the base map, we're setting this base layer property to a Cesium imagery layer, and we're pointing it to ArcGIS imagery. Something really magic about Cesium is that they have built-in support for ArcGIS base map services, ArcGIS image tile base map services, that is. And so we don't have to reference a URL or anything. They have this class called ArcGIS Map Server Imagery Provider, and they have several different base map types enumerated. So to create a base map, we basically point it to this base map type called satellite. And then really it's just this one-liner that we set. And we say imagery layer.fromProvider, ArcGIS imagery, and this is going to load it all in. Again, with all of our base map services, it does require an API key. So we're using an ArcGIS API key here. Just like Anita showed, you have to paste this into your app for it to work. To use Cesium as well, Cesium also has a service called Cesium Ion that it is monetized, but there is a free tier and everything. And you do need to include a Cesium access token to build apps with Cesium. And this token is actually not being used at all in this app because it's pretty much all just ArcGIS services. But you will need to include your access token. It's totally free to create, but it is required for the viewers. Scrolling down a little bit, we'll get to the actual data. And this is the same service URL we saw in the OpenLayers app. We're creating the Santa Monica Mountains parcels as an ArcGIS map server imagery provider. Again, Cesium has a bunch of built-in classes for ArcGIS data, so they have this built-in class that makes it super easy to basically any map server. So if it has the URL map server if it has the word map server in the URL, all you need to do is paste it into the map server provider and load it into your app. We're passing our token as well, and this is going to be required if your data is private. Maybe you have the layer set to be just you or just within your organization. So the token is going to authenticate that. And then to actually add it, we say from provider async again, almost exactly like the base map. And this is just me manually adjusting the hue and saturation and brightness to make it orange. It's actually really easy to style map tile layers in Cesium, which is very convenient. So yeah, just a pretty short app resulting in a lovely 3D scene with terrain. I love Cesium. Awesome, so that was map tiles. Let's move on to the final data service type that we're going to cover, which is a scene layer. We're going to be sticking in Cesium with this one because it's the only library that supports scene layers currently. So scene services, it's actually a really broad blanket term for all sorts of different types of data that's stored in 3D. If you think about city skylines or buildings, integrated mesh layers, 3D object, I think there's 6 or 7 different types that are outlined by the scene layer specification. And ArcGIS, you can store any of them as a scene layer in ArcGIS. Currently, you can only load scene layers in Cesium. The JavaScript Apps SDK, I believe, fully supports all the types. Cesium currently supports what's known as 3D object layers and integrated mesh layers. There's a few other types like voxel layers, point cloud, point layers, and building scene. So definitely check out the Maps SDK if your use case requires those. And all of the scene layers adhere to what's known as the I3S specification. I3S stands for Integrated 3D Scene Layer, and this is an open standard that's maintained by Esri, actually entirely and published by Esri too, and accepted by the OGC. So thank you, Esri, for maintaining open standards, at least this one. And so, yeah, I3S is honestly a really, really nice data format, and it's fully supported, or it's mostly supported by Cesium. Actually, someone from Esri added support to it, so a great example of the open source community at work. To add a scene layer in Cesium, there is an I3S data provider class. Let's just check it out, because I do love a strong visual grounding for this kind of thing. So for this one, we're actually just going to go back to our developer documentation. Just like with the other open source libraries we support, we have a whole dedicated guide to CesiumJS. And if we go to the data services chapter, we have 2 tutorials about scene layers, the add 3D objects and add an integrated mesh. It might take a second to load all the data, but soon we will see the San Francisco skyline appear. Probably should have loaded this in advance, honestly. Sorry, y'all. And again, this is just using the i3s data. Here it is. So this is what's known as a 3D object layer. It's stored within a scene service in ArcGIS Online. And just full screen, perfect. So yeah, this is the San Francisco skyline, and you can see the scene layer that we're loading in has textures for all of the buildings. It has the building shapes. You know, it has some pretty complex and relatively high resolution textures for just kind of a random layer we found. And it's a great way to visualize a skyline. Maybe if you're building digital twin of your city as part of a city government project, or if you're simply trying to enhance your visualization capabilities, you can actually load in any kind of other data layer we've seen on top of this, barring vector tile. If you want to load your feature layers and have them, appear on top of the building, you can clamp to terrain. There's all sorts of options that you have in Cesium. And the CesiumJS guide on our website has a bunch of examples of this where we're calculating service areas over a building layer, and it just looks great. So really good use case for Cesium. Let's take a look at the other Cesium app that we have as well. It's called, that displays an integrated mesh layer. And both of these, they're different data types, but they're added in exactly the same way as they're both stored as scene layers in ArcGIS Online. So this is another type of scene layer, and it looks very similar, but instead of storing each individual building as a separate, basically, feature, that's what the 3D object layer does. The integrated mesh layer is almost like the raster equivalent, where it's just one giant blanket that contains all the buildings with elevation data and textures. This type of data is typically generated from maybe like drone or satellite imagery from multiple angles, and then basically just fully assembled. So it's another great way to get a 3D skyline. And this one, if we zoom in a little bit, you see it actually includes like models of all the trees, all the cars that were on the road at the time the imagery was taken. It basically does everything. Like if I was walking in the city, I would be a little dot on this layer too. So yeah, this is the layer. Let's take a look at how to add these. And the steps are literally pretty much exactly the same for both of these. So let's just look at the mesh one. And we'll see right away a lot of the same code I showed you for the map tile. We do require API keys for everything and Cesium access tokens. We're going to make a Cesium viewer and set the camera. And then to actually create the integrated mesh layer, this is the class that you need to use in Cesium. It's the i3s data provider, so integrated 3D scene provider. And all we have to do is point it to the URL of our building scene layer, or our integrated mesh layer in this case. So this is the service URL again. This one is called Buildings Frankfurt 2021, which I guess was the year the layer was created. And yeah, we're adding it to the map. One additional thing you'll need to do with scene layers is give it a reference to a GeoID service. And this is to make sure that the building's clamped to terrain properly. So basically we're using an additional thing called a GeoID service to georeference the buildings and make sure they sit on top of the terrain instead of clipping through it. And we have more documentation on how all that works in the Cesium guide if you're curious for more. And then, yeah, all you have to do once you reference the layer is add it to your scene as a primitive, and it should display on your map. So that was scene layers, 3D object and integrated mesh. I think that was all the data types that we have for today.
I will say that even though CesiumJS doesn't support vector tile layers natively, with the new static base map tile service that will be coming out in beta soon, you will be able to access some of the pre-rendered map tiles, so navigation, streets, and others. So that is a feature to look out for as well.
That's a great point. So we'll actually be able to get the base map styles in Cesium instead of just ArcGIS satellite. That's perfect. Cool. All right, so there are a couple services, like Anita mentioned, that we're not covering today. We have a talk called Advanced Open Source Mapping on Friday morning that we're going to go into much greater detail for all of these. Here's just some screenshots of apps that we've built using them. On the top left, you can see a routing app that uses the routing service got a Places service app in there that lets you find points of interest in restaurants near you. You can perform spatial analysis, such as hotspots. And you can even use like geocoding or geo-enrichment to get data about the places that you're near. Yeah, all of these are using ArcGIS REST.js. That's an open source library published and maintained by our team at Esri. And that allows you to make service requests and get the data back from them pretty easily. And it's really easy to integrate REST.js with the libraries we've talked about today. It's just a little bit outside of the scope of this talk. So we'll save that for another day. For now, what are the takeaways from this? Well, we learned about 4 new open source libraries today. We've got Leaflet, Leaflet, Cesium, MapLibre, and OpenLayers. And they're all very comparable, especially the ones that aren't Cesium, because they are 2D mapping libraries that support vector tile, support all the same data types pretty much. So you might be wondering, like, when should you use Leaflet versus MapLibre? We have a few bullet points here to try and help you make your decision. Again, it's going to be guided off of your use case. So I think the best things about Leaflet personally are the very small library size. It's the smallest footprint. It's also the most active community, and it has the most weekly downloads on NPM. So if you're looking for support, Leaflet is probably a good place to go. There's a lot of existing documentation for it. There's also a lot of plugins available for it. It's very easy to extend Leaflet and make your own plugins as well. And there's additional frameworks, like there's React Leaflet if you want to build a React app, and Angular, things like that, which I believe the other apps, like OpenLayers and MapLibre, definitely have that as well. The major con of Leaflet, in my opinion, is that there's no WebGL support. So WebGL is a rendering program used by your browser, and it makes things way more performant. MapLibre GL JS, as you can guess from the GL, has full support for it. Leaflet does not, unfortunately, except if you want to display vector tiles, you can use Esri Leaflet Vector, which is a plugin we offer, and that does use WebGL. So that's pretty much the only way you can display data using WebGL in Leaflet. Moving on to MapLibre. Like I just mentioned, it has the best support for WebGL, and Anita and I have also performed a good amount of performance testing on these libraries. We have a previous talk published on that, actually. And our findings is that MapLibre was all around the most performant overall, especially for vector tile and map tile. I think Leaflet was pretty comparable for features. Or GeoJSON.
GeoJSON,
yeah.
Yeah. I mean, all of them were pretty comparable with GeoJSON. It was the vector tile layers that were really
Yeah, again, because of the WebGL.
Exactly.
Yeah, OpenLayers doesn't use WebGL either, which means it's much slower for vector tile. The major cons of MapLibre is that the community is much smaller right now because it's the newest. It was just published in like 2020 or something like that. And that also means that the plugins are very limited for it. In fact, most of the plugins are still plugins for Mapbox that are outdated at this point. So that's something I've personally run into. It's a bit of a gripe, but yeah, overall, it's a really strong library, especially if you're building something lightweight just to show off some data. The next library that we're going to talk about is OpenLayers. I'd say the major pro of this is that it has way more support for, like, it's very robust. We didn't even scratch the surface of what OpenLayers can do today, but it lets you do all sorts of GIS operations like coordinate transformations and mapping between different data types that the other ones just don't have support for. And that's largely because it's been around since 2006. It's like 18 years old at this point. So there's a large body of work on OpenLayers. It's supported by all sorts of institutions. And definitely, if you're looking for something a little bit more involved, then this is a great one. The major con is kind of the same as the pro, is that it's very involved. It's almost 20 years old, and it has a pretty steep learning curve because of that. Especially if you want to make something simple, it could be a little bit trickier to do in OpenLayers as opposed to something like MapLibre, just because of that learning curve and having to do coordinate transformations and things like that. The other major con is that it doesn't support WebGL. There is an experimental class in the new release for vector tile layers, I believe, but that's still in beta. Maybe you could check it out if that's a use case you need. But yeah, maybe save this one for the more involved apps. The final library is Cesium. And like we saw, it was really great for 3D scenes. It's the only one that supports 3D. It also supports, obviously, I3S layers and all sorts of other bells and whistles. Like you can put 3D models in it. You can animate the models. You can do like time dynamic visualization. So you could animate like your airplane flying over your city if you wanted to do that. Use Cesium. The major con is that the library size is a lot bigger. It's slower than the other ones because it has to render a whole 3D world. and that also makes it pretty GPU intensive. And finally, we've said this like 10 times already, but there's no support for vector tile layers in Cesium, which is the major con. Right, I think that was everything we have for y'all. Yeah. So if you have any questions, this is a good time for it. Anita also has this wonderful survey published about feedback on the open source documentation, but also all of our developer documentation. So please scan this QR code and take our survey. If you have a few minutes, would definitely help us improve the doc. But I think that was it.
Yeah. That's it. All right.
Awesome. So we'll be taking questions for the next few minutes, both on the live stream and in this room. So.
Yep.
Yeah.
Or if we have no questions, I mean, we can. Okay. Yes.
Right. Well, Esri Leaflet is still actively supported.
You should repeat the question for the.
Oh, great. Great question. So the question was, what's the future of the support of Esri Leaflet? Because maybe there's been rumors of the support going away. Definitely, Esri Leaflet is still fully supported. I actually personally contribute to Esri Leaflet and Esri Leaflet Vector, and I'm one of the maintainers of it. So definitely still working on it. Right now, I'd say it's in maintenance mode. We don't have plans for any significant new releases, but we are obviously keeping it up to date with the latest versions of Leaflet. And every time we get a location service update, we make the appropriate updates to Esri Leaflet. For example, we just released the basemap style service v2 recently, and that is fully supported by Esri Leaflet Vector as of like a few months ago. So.
Yeah. Yeah.
There are a few plugins that we no longer support. We used to have a renderers plugin for Esri Leaflet, but that's no longer recommended. Hasn't been up to date for like 5 years.
Yeah.
But.
And a lot of it, like, yeah, I think that was to do with people wanting like that web map support, but Leaflet isn't the library for that. And so that was one of the plugins we just decided not to keep up to date. But definitely, whenever there's a new location service out, like places, basemap styles, we actively update Esri Leaflet to support those capabilities.
Right.
Yes. How do you, the question was, how do you obtain an API key? So I don't know, George, if you want to go to the developer site. Yeah.
So to make an API key, you need to have an ArcGIS account. You can use ArcGIS Online or a developer account. I'm logged into my ArcGIS developer account, also known as ArcGIS platform. And you go to developers.arcgis.com, and you go to your developer dashboard. All you have to do is click on the API keys button and click New API Key, and then API Key test or whatever. And once you click Create, here's your key, and I'll just delete this right after, so don't care about exposing it. But generally, don't share this with people. All you need to do is copy this and then paste it into your application, and it'll work like magic.
Yeah.
Yeah, so this is a permanent key, and this is never going to change or go away unless I delete it. So you basically just create this one time, and then you just have to copy paste it into the application, and it'll work. There are other ways to get access tokens, but this is probably the easiest. So.
You do have to also be sure to scope your API key to a specific service. So for example, if you do want geocoding or routing, you go to this UI that George is showing, and you check the boxes. If you have a developer account, you can also scope your feature layers, vector tile layers, map tile layers to an API key as well.
Right. If you wanted to access your vector tile layer that was private or something, you could set the scope here. Mm-hmm. And we have an authentication talk in ArcGIS at like 5:30 today, where we go into much greater detail on how to do all this. It's called Security and Authentication in Custom Apps with ArcGIS. I don't remember the room right now, sorry. Which I probably should, because it's my talk. Right. So if I understand the question correctly, it's like, when do you need a username and password to access a service versus like an API key? And will you ever get prompted for your username and password when using an API key? Is that correct? Or to my understanding, an API key is never going to prompt you to enter a username and password. We do offer what's known as user authentication, and that is a method where you do enter your username and password, and it is required to access certain geoprocessing tasks, like you mentioned. API keys are currently, in their current form, are not able to access things like the spatial analysis service. The extent of API keys access are the location services, so pretty much most of the services you see here, maybe a couple others, and you can also access private content items with them. But if an API key isn't scoped to access a content item, it's not going to be able to access it. It won't ask you for a username and password. It'll just break your app probably. It'll throw an error.
Yeah. There's some question in Pigeonhole, and just to go on the API key train of questions, are there any limitations in API key usage? And as Georgia was saying, yes, there definitely are. In addition, you cannot create a feature layer with an API key programmatically. Or no, yes, you can.
Yeah, I don't think you can create one. No, you can edit a feature layer, but not create.
Yes, that's correct.
Yeah. So definitely a few limitations.
Yeah.
There is going to be an update later this year to API keys scopes that will allow them to do pretty much anything that you could do with user authentication. So keep an eye out for that. But yeah, what's...
Where can we find the PowerPoint?
The PowerPoint will be available, I believe, after the conference is over, in the proceedings, I believe.
It should be on the speaker portal or something, or on the Dev Summit portal online, right?
I
I'm
think
not actually
so.
sure.
Yeah.
We're
No,
also
they will, like the PowerPoint slides will be available definitely after the conference. So
we'll also include a link to a GitHub repository that has all the code we showed. So we'll just put that on the PowerPoint slides. Yeah. Will the slides be available for all sessions, or? I'm not sure actually, but I think it's all the ones that are
I would
like
think so.
recorded at least. All of the technical sessions for sure.
all the technical sessions, PowerPoints, I think should be available.
You were using the term map tile service and map feature service. There's also like web map feature service and WMS and stuff. What's the difference between them?
Yeah, that's a great question. The question was, what is the difference between map tile service, WMS, and what was the other one? WFS, yeah. Web feature service, web map service.
Well, I haven't personally worked with WMS or WFS services that much, so I'm not sure if we have.
We do have, I know on the Mapping APIs and Location Services Guide, we do have some examples. I think if you want to learn more, I'm sure it's in the API reference.
Yeah, definitely.
Yeah, but let's see. I'm going to go to Maps, and I think it's under Layers. Data layers. We have some code examples here, at least for displaying data from a WMS service. So I don't think I'm too familiar with WMS, besides it being an OGC standard. I haven't worked too much with it.
I don't know if we even have a code sample for open source here.
No, we don't.
This should, it looks kind of funny. But yeah, this isn't something that we've personally tested with OpenLayers or Leaflet or any of them, but it could work. So we'll have to look into that more. We might publish a new sample or tutorial on it if we find that it is compatible.
Yes, but if you do want to learn more, it looks like there is an OGC link that should open here. If it loads.
Pretty positive that it is compatible with the libraries, but we're not sure about ones that are hosted in ArcGIS. So,
Yeah.
But should be. Should probably be the same method that we showed for the other ones. Any other questions?
All right, I think I think we can call it then. If there are no other questions.
I don't think there are any other questions. Someone says I'm running out of battery. Oh no,
Yeah, I think you are, yes.
tragic.
All right, well, thank you so much for attending our session, and please come up and feel free to ask us any more questions, or if you have any comments, please, we want to know. All right, thanks.